Hello, everyone. Hello, everyone. Good morning, good afternoon, and good evening. And thank you for joining me live in today's Cloud Native Data Management Day webinar. Today, we'll be talking about demystifying data protection for Kubernetes. And let's start with some introductions. My name is BHAVIN SHAH, and I'm a technical marketing manager with the Cloud Native Business Unit or the Portworx Business Unit at Pure Storage. I've been working on the operations side of DevOps for the past 8 years, building solutions with converged infrastructure, hyper-converged infrastructure, private cloud, hybrid cloud, and most recently for the past 2 or 3 years, focusing on Kubernetes solutions. So you will see a trend in this short presentation that we have of me trying to map things back from the Kubernetes landscape into more of the virtualization stacks that we all are familiar with. We'll go for around 30 minutes in this presentation. The first half is focusing on slides and just general trends that you can apply when thinking about data protection for modern applications. And then we also have a demo for you planned. So let's look at the detailed agenda. Okay, so we'll start by talking about why is backup important. And again, not spend too much time there because I feel that all of us know why backup and restore is a critical component to business continuity and the overall success of the business. But we'll focus on the different challenges that you might face when you're thinking about data protection for modern applications that are built using containers. And once I have convinced you that you need a newer solution or you need to think about it differently, we look at the requirements for a modern data protection solution. So what are the design considerations? What are the different elements that you should look for when you're selecting a new solution? And then in the latter half of the presentation, we'll talk about one such solution. We'll choose pxBackup from Portworx or Pure Storage as the data protection solution. And then after just talking about it for a slide or two, we'll jump into the demo and look at a simple WordPress application that's running on a GKE cluster and how you can protect that using pxBackup. So I hope everybody's excited. And if you are watching this on YouTube live, please remember to subscribe to the channel. We have a webinar planned for you for like a month on a monthly cadence. So you can always find more and more interesting topics that people are talking about on this channel. Let's dig in. Let's start by talking about modern apps data protection challenges. We'll start the discussion by talking about why is backup essential for enterprise applications? And again, it is something that you have got to do if you are dealing with a production environment. Regardless of whether your applications are running on top of virtual machines or they are running on top of containers. The reasons can be varied from organization to organization. It can be just about data protection. So you need to protect your data from accidental deletion, corruption, exfiltration, etc. Or it might just be that you have to comply with local regulations like GDPR, like HIPAA or the CCPA. One of the Article 32 of GDPR actually states that you need regular backups. That's essential. So one way to avoid those huge fines is just to comply with it and have a backup or a data protection solution in place. And then regardless of the reason that you are using or having of implementing a backup solution, you need a solution that allows you to restore quickly. Based on a research survey done by 451 Research, 53% of enterprises need an application to be restored to its original state in less than an hour in case of a disaster. So you need a solution that not just allows you to protect your applications, but then in case of any disaster event, allows you to restore your applications quickly and get you back online. Talking about surveys, let's talk about another one. Let's look at the ESG research report around data protection trends and strategies for containers. Again, you can go and read the whole report at length. But for this presentation, I would like to just pull out a couple of highlights that I would like to discuss. The first one being containers are mainstream today. So 2 out of every 3 respondents to the survey, and I think the survey was for 430 or 450 people. So 2 out of every 3 respondents is already running containers and container-based applications in production environments. So As a community, I think we have crossed the chasm, and we are more comfortable with not just building applications using containers and microservices, but also running them in production environments for any and all kinds of applications that are built using the 12-factor principles. The second statistic is around containers are more prevalent than virtual machines, or will be in the next 24 months. So if you are an admin today and you don't see many container-based applications, most of your production workload or environment still runs on top of virtual machines. That's going to change. Like containers or applications built using containers are going to have a huge growth curve and catch up or even surpass virtual machine-based applications that are running in your production environments. And then the final statistic that we want to talk about today is 71% of the respondents actually plan to deploy containers, not just in one environment, but across their on-prem data centers and different public cloud vendors. So you need a solution that can help you protect these applications that are deployed across different cloud environments. But one of the things that concerned us, like looking at the survey, was there are some misperceptions that are pervasive right now. Like if you look at just a simple question like, can you use the same backup solution for a container-based application that you have used for your individual applications? 75% of the people said yes. And that's something that we hope to influence with this presentation. So if you are in the 20%, thank you for leading the way, and thank you for adopting newer solutions. But if you are in 75% or even in that 5% who don't know, hopefully this presentation gives you key takeaways that you can think about and then evaluate your production environments and your applications. So let's look at why traditional backup methods don't work for containers. And we'll keep this simple. I won't bore you with a lot of slides. We'll just give you 3 reasons of why traditional backup methods don't work. The very first one is traditional backups are machine focused. So if you are like me and you have worked with VMware environments and Microsoft Hyper-V environments, you know that you can deploy a hardware or a software-based backup solution and point it to these to either a vCenter instance or a System Center virtual machine manager or a Nutanix Prism instance for that matter. The backup solution is smart enough to enumerate or inventory all the different VMs that you have running. And then it basically allows backup administrators to create backup jobs and policies to meet the SLA requirements that they have for their applications. So, but this doesn't work when it comes to container-based applications, because each virtual machine or a bare metal node can be running more than one application components. So container-based applications are distributed in nature. So you can have a single application that's spread across multiple nodes, and a single node or a single machine can be running components from different applications. So if your backup solution is just aiming at a machine or a node, you might not get all the different components that are needed to protect a container-based application completely. Second is traditional backup doesn't speak Kubernetes. So similar to how your traditional backup solution spoke to vCenter and it got you a list of VMs and resource groups and enumerated all the data sources, you need a solution that can talk to the Kubernetes API server and enumerate all the namespaces, all the different applications, all the different Kubernetes objects that are running inside your cluster. You need a solution that can talk Kubernetes. And then the final one is traditional backup is more centrally managed. The roles and responsibilities for managing or protecting traditional apps is different. You might have like a team of backup administrators if you're a large organization, or you might have a backup admin whose sole job is to meet with individual teams, agree on SLAs, and then configure backup policies so that those SLAs are met. But with the DevOps movement, self-service is one of the key constructs. So your application developer and application owner might know how to best protect a specific application, while at the same time, the cloud administrator might want to ensure that your backup target or your backup repository is sitting in a region that complies with local regulations or is using encryption at rest. So we need a solution that helps provide self-service capabilities for all the different personas that exist inside your organization. And if you're trying to retrofit your traditional backup solution for your container-based application, you might be at a risk and you might leave your applications and your business exposed to data loss, to slower recovery times, to no self-service capabilities, and maybe even needing manual intervention when it's time to restore. So you don't want to be in a situation where you have to put the puzzle together or put the Lego pieces together when it comes time to restore, leaving you at a risk of longer recovery times or maybe even data loss if you can't put the application together the way it was supposed to be. So you need a solution that understands all of these things. And without that, if you're just using a traditional backup solution, according to GigaOM, you might be at a risk of data loss, downtime, and lost customer loyalty, which doesn't sound like great things. So let's talk about how you should select your next solution. What should you be looking for when you are thinking about modernizing your data protection stack? So understanding is one piece which we covered. Let's focus on the design considerations or the requirements. And again, we'll keep this simple. We give you 3 challenges. We'll give you 5 different essential elements that you have to keep in mind when you're talking about or when you're thinking about a Kubernetes native backup solution. So those things, again, we'll look at each of these things in detail in the next few slides, but just to list them off, your backup solution should be container granular. It should be Kubernetes namespace aware, should help you with application consistency and not just crash consistency. It should be capable of backing up your application, your data, your Kubernetes objects, everything as one. And then it should be optimized for multi-cloud. So let's see what we mean by each of these terms, right? First, container granular. If you look at the image on the left, you will see that each node in that forms this Amazon EKS or AWS EKS cluster is running components for different applications or is running containers for different applications. So you have your green application, you have your purple application, and then the gray blocks are just system level binaries that exist on the node. So your data protection or your backup application should be able to look at these nodes, identify the containers that make up your application, and just protect those, not the machine, which can cause to you may be spending more money storing these backups, and then which can also lead to longer recovery times. Next should be Kubernetes namespace aware, right? So you should be able, your backup solution should be able to talk to your Kubernetes cluster and identify all the different namespaces and identify all the different Kubernetes objects. So this can be anything from pods to deployments, to services, to custom resources or operators you might have as part of single application. So your backup solution should be able to query the Kubernetes API server, get all of these details, and then help you protect them with a single click or with an easier way of selecting these components. Next is application consistency. So again, when you're dealing with containers, when you're dealing with distributed stateful databases, you need a way to ensure application consistency. So whenever you're taking a backup job, you need to, your backup tool should be able to allow you to take application consistent snapshots and not just crash consistent snapshots. Application consistency can be achieved if your backup tool allows you to specify pre and post backup rules. So again, this is where you can specify things like, okay, let me quiesce the IO, let me flush everything from the memory to disks, and then take a backup snapshot so that when I restore, I get an application consistent restore and not just a crash consistent one. So there's no data loss. Fourth thing is your backup solution should be able to protect everything from your persistent volumes that store your application data to your application configuration, which might be stored in Kubernetes secrets and config maps, to your different Kubernetes objects that make up your application, right? So you can have your pods, your services, again, all of those different resources that we just spoke about. You don't want a tool which does just a persistent volume and then you need to rely on a second tool for different Kubernetes objects, because when you try to put those together, you will have a longer recovery time and you'll have a hard time restoring your application. So you need a solution that takes an end-to-end application overview and helps you protect the application as a whole. And then the final thing is it's optimized for multi-cloud. So if you remember the statistic from like 10 minutes back, 71% of organizations are looking to deploy containers across on-prem and public cloud environments. And this is where your backup solution should be able not just to run in any of these environments, but also talk to the different managed or DIY Kubernetes clusters that you might have running on-prem or in public cloud, and be able to protect applications running on any of these infrastructures that you choose. So as long as you remember these 5 things, you should be able to pick out a good solution that will help you protect your container-based application. So as the second half of this presentation, let's just talk about one such solution that checks all of these 5 boxes. pxBackup from Portworx is built for containers and Kubernetes, and it helps you take an application consistent and end-to-end application snapshot, which can be stored in any S3 compliant object store. So pxBackup is part of a huge portfolio from Portworx that tries to help customers and organizations and users provide storage for your Kubernetes cluster environments. pxBackup handles the data protection side of things. It allows you to connect pxBackup to any Kubernetes cluster that you might have, identify all the applications that are running on it by namespaces and like sorted by namespace or sorted by labels, and then store those snapshots in AWS S3, Azure Blob Storage, any other S3 compatible object store that you might have on-prem or in the public cloud. And then when it comes to restore, you can use these snapshots to restore it to the same cluster, or you can restore it to any other cluster running in a different infrastructure maybe. So depending on the failure scenario that you're going through, you can, if it's just accidental deletion, you can perform restore to the same cluster. If you need to, if you lose your cluster as a whole, you can restore it to any other cluster in the cloud as well. So that's it for the slides. Let's move on to a demo and see all of this in action. Like we'll just do a quick 10-minute, 15-minute demo to walk through all of these concepts. What I have here for you is just a simple 3-node GKE cluster that's running in the US East 1 region, running version 1.19. And then from a backup perspective, since this is just a demo, I am running pxBackup on the same cluster. And again, I deployed this cluster this morning. That's one good thing. All of this is easy to deploy and experiment with. And what we'll do as part of this demo is we'll deploy a simple application, a simple WordPress app. So we have a MySQL backend for persistent volumes, and then to store your data. And then we have a WordPress deployment as well, which is more of the front end component. So let's go ahead with the deployment, and then we'll walk through the pxBackup UI. So while this is getting deployed, we'll deploy it in a specific namespace because we want to distribute, like have multi-tenancy in the cluster and deploy multiple applications on the same GKE cluster. So let's see if how these are progressing. And then we'll give the application a few minutes to come up. Right now it's in container creating state. So let's wait for it to come online. And in the meantime, let's navigate to the pxBackup UI and look at the different things that we spoke about, right? So one of the things is cloud settings. So you can associate any of your cloud backends. Again, since this is running in, this demo uses GKE, we are connecting to my Google Cloud account, and then we have configured a cloud object storage bucket that is attached using a service account inside Google, my GCP account. So we have the cloud account ready to go as part of this demo. Next thing, that let's look at schedule policies. So again, this is where you can specify different schedules which your application owners or developers can use to protect their application. So by default, like you can, as an admin, you can create new policies on a periodic, so it can be every 15 minutes or every hour, or you can also create new policies that are on a daily, weekly, or a monthly cadence. So as an administrator, you get full control over when the backup snapshot is being triggered and how many copies of the snapshot do you want to retain, when do you want, how many copies of incremental backup snapshots do you want to keep. So for this demo, I've already created 3 schedule policies that can be leveraged. And then the last thing that we look at is just the rules. So here we have, again, you can find more examples on our website, which is just linked through here, talking about stateful apps, right? You have your Cassandra, your Elasticsearch, MongoDB, MySQL, PostgreSQL, all of those applications. We have rules that you can just use out of the box and assign those inside your pxBackup installation. So we have a pre-rule and a post-rule for Cassandra. Same thing for MySQL already configured. It's as simple as giving it a name, specifying a pod selector or a label selector, and then specifying the action. So again, for Cassandra, when before a backup snapshot is triggered, we'll just flush. You do a node tool flush to ensure application consistent backups. So let's go back to the UI. Again, since we deployed this cluster this morning, we already have one app that's being protected. And it's storing some amount of data. So this dashboard gives you a view of how many protected apps you have, how many schedules you have in place, and then how much data is actually being protected. And you can add one or more GKE clusters. So you can have a pxBackup installation that connects to all your GKE clusters in the same region and enables you to protect all the different applications. So let's see if our application is up and running. So pods look good. We do a service just to get the load balancer endpoint for this particular WordPress instance, and we'll navigate to it and go through the basic setup for WordPress. I want to keep a simple password for this demo, but again, oh, forgot the email address. Okay, let's log in and customize this a bit. So when we back it up and restore it, we know that we restored the application as we wanted it to. So we just add a new post. Data protection demo using pxBackup, and then just be published immediately. So if we navigate to the site, you will see that, okay, we have a new post that was just published. So let's go to our pxBackup UI, and we selected our GKE cluster. Let's select the WordPress namespace. So this is where I want you to pay attention. So you can either select all namespaces or a specific namespace. Once you select a specific namespace, you can, pxBackup will basically list all the different components for you that are part of that namespace. You can have multiple backup policies. Again, you can customize this however you want, but you can select, you can choose to back up all the different components and your entire application as a whole on a daily basis. But then since Kubernetes objects don't change that often, you can have your persistent volumes being protected at an hourly or every 15-minute basis. So you can have different SLAs for application uptime and then use pxBackup to configure those things. Here, we'll protect everything except the resource quota that was specified by GKE, and then we'll hit backup. You can give a simple name and then select the backup location. Again, this is a cloud object storage bucket. Snapshot, again, pxBackup can work directly with AWS, EBS, Azure storage, GKE persistent disks without the need for running our px store product. So we can take snapshots directly from those cloud endpoints. Here you can select whether you want to take this backup on a schedule, and it will list all the different schedule policies that you have configured, or you can take one on demand. So let's do an on-demand one because we want to have the backup run right now and then try to restore it as well. So we can create this simple backup job and monitor the progress and look at how many, what's going on. You can click on show details. And right now, since it's in progress, let's click a different tab and look at the other things that pxBackup enables you to do. So if you have applications that you need to protect on a schedule, you can go to the schedules tab. And here I have a Postgres application that was generating some data. And I want a daily backup that's executed at 9 p.m. Eastern every day. And then I want a monthly backup that's scheduled for the 30th of every month that executes at 10 p.m. Eastern every day. So I can look at my schedules and look at whether all of these are active or not. And then coming back to the backups tab where all of the on-demand backups show up. So the WordPress demo backup job that we just kicked off is now successful. It backed up 10 resources. So these are the different Kubernetes objects. And then it restored, it backed up 2 volumes. So we can click on show details and find more details like, okay, it saved a couple of deployments, persistent volume claims, MySQL password, which was stored as a secret, and then a couple of services that were deployed as part of the application. So all of this was backed up as a single unit using pxBackup and was stored in our cloud object storage bucket. So let's go back to the CLI and delete this application, right? This is the fun part of the demo. Whenever you're doing a backup and restore demo, so we can do a get all to make sure everything looks exists right now, and then we'll just delete everything. So we have a couple of pods, services, deployments. Let's just delete all the resources that we created in the WordPress namespace. So this will delete everything that we just protected and backed up. And while this is happening, we can go back to the pxBackup UI, and you can go to the backup tab and select, if you have multiple backup jobs, right, where you protected this application, you can select which one you want to restore it from, or if you want to restore it from a schedule, like if you found out that you need to restore it at like 8 a.m., but the backup that you took last night is the latest one, you can come to the schedules tab and then select to restore from it. Let's see if the application deletion was successful. So we'll do a get all again. And as you can see, we no longer have any resources that are running in the WordPress namespace. So using pxBackup, we can just hit restore. And a couple of things to note here. So we can do a simple restore, just give it a name, select a cluster. So I can, right now, I only have one cluster associated with my pxBackup instance. So that's the only one that shows up here. But if I want to move it to a different cluster, I can do that too. And then I can do a default restore, so it restores it in the same namespace. But if I want to customize it, if I want to take application from one namespace to another namespace, I can enter in the destination namespace as well. If I didn't delete all the different application components, maybe I just deleted one persistent volume, I can select to restore just one thing. So instead of selecting all resources, I can just select, okay, I need to restore a specific persistent volume as part of this restore job. But in our case, we deleted everything. So let's just select everything. And we'll replace existing resources. So again, if you are restoring it back to a previous well-known state, you can select that box and then hit restore. And at this point, pxBackup basically fetches the backup snapshots that are stored in your cloud object storage bucket and restores it to your GKE cluster. You can use the pxBackup UI to monitor the progress. Again, it should take just a couple of minutes for the restore to work complete successfully as well. And then let's do a get pods in the WordPress namespace and just watch it. Watch the pods being spin up and come online. So again, since this is restoring a container-based stateful application that had 10 different Kubernetes resources, application configuration stored in secrets, and persistent volume that was stored in a couple of PVCs that were running on Google persistent disks, or PVCs that were deployed using the standard storage class inside GKE. All of this was backed up, and now we are just trying to restore it. While this happens, while the restore is in progress, let's go back and look at all backups. So this is another view that you can get where you can look at all the different backups and restore operations that you have in place. Here, backup, just before we started this presentation, I just wanted to test and make sure. So I have some deletions going on as well. But we can see our successful backup that we did at like 5 minutes back in place. And then let's see where we are. Nothing yet. So it takes a couple of minutes again for the whole application to come online. While this, like, if you want to add more clusters to the pxBackup interface, all you need to do is just give it a name, use this simple command to add a new cluster, and then paste whatever output you get from your CLI in terms of the kube configuration, and store it and paste it here, and it will easily communicate to your cluster and add it to the pxBackup UI. And then you can inventory your Kubernetes cluster, identify all the different namespaces, and start protecting your different applications. So Let's go back. Okay, the pods are still not up. Let's switch back to the slides while the restore is on its way, and we'll come back and verify that the restore worked. So if you want to learn more, we have multiple demos that are on our YouTube channel or Portworx YouTube channel. We'll have more content on the cloud native data management channel and website as well. So make sure to subscribe to both of those. We have additional white papers, solution briefs. You can deep dive into our documentation. If you want to try a hands-on or like do a free trial, pxBackup has that as well. So you can navigate to portworx.com and basically do a free trial of the product against your applications that are running on your Kubernetes clusters, regardless of the infrastructure. So feel free to go ahead, and that's it for the slides. Let's just see, and let's just make sure that our application came online. If you have any questions, feel free to put them in the comments. If you don't get to it in the live stream, we'll come back, and I'll basically come back and go through all the comments and then reply to those. Again, if you want to reach me, I shared my social handle on the first slide, BHAVIN04890. That's basically how you can reach me on Twitter and LinkedIn. And if you have any other questions, again, feel free to put them down in the chat. Switching back to the CLI, as you can see, we have our pods went from pending to container, creating to running. Let's look at the services. We have a new IP, and then let's look at the PVCs that are running. So now we have, we restored the two persistent volumes that were part of the application 97 seconds back. So let's try navigating to the load balancer interface again. And as you can see, our site and our post that we initially created as part of the demo is back online. So we didn't have any data loss. Again, this wasn't a Cassandra demo. This was just a simple WordPress site. So we couldn't really test the application consistency piece, but you can use pxBackup to do that as well. This is just restoring a stateful application that's built using containers and all the different components that are protected by pxBackup. So now that the restore is successful, that's it for this presentation. Again, thank you again for joining. We'll have more of these in the future, so please subscribe to the channel. And with that, thank you for joining. Have a great evening, everyone.